Hello friends, welcome back to Secret of Electronics. In this video, we will learn how to make a simple object color detector using an Arduino Nano, a TCS3200 Color Sensor Module, and an SST1306 OLED display. In this project circuit, our Arduino Nano acts as the central controller, connecting both the TCS3200 color sensor and the SST1306 OLED display. The TCS3200 sensor uses four control pins S0 and S1 on D4 and D5 to set the sensor's frequency scaling, and S2 and S3 on D6 and D7 to select the color filter. The out pin of the sensor goes to D8, where the Arduino reads the output frequency corresponding to each color. The sensor is powered with 5V output of the Arduino Nano. On the display side, the SST1306 OLED communicates using the I2C interface, so its STA and SCL pins are connected to A4 and A5 of the Arduino Nano. The display also uses 5V output of the Arduino Nano. This simple wiring allows the Arduino to read color information from the TCS3200 and instantly show the detected color name on the OLED display. This Arduino code reads color from a TCS3200 color sensor, converts sensor pulses into RGB values, decides the color name, and shows it live on an SST1306 OLED. Start by loading the I2C and Adafruit display libraries so the Nano can talk to the SST1306 OLED. Then we define the display size and create an Adafruit underscore SST1306 object for a 128 by 64 screen. In setup, we call display.begin, clear the screen, set text size color, and print a welcome message. This gives the viewer instant feedback that the project booted correctly. The TCS3200 has control pins S0 and S1 that select the output frequency scaling, and S2 and S3 to choose which color filter the chip reads, red, green, blue. The out pin produces a square wave. This frequency depends on the light passed by the selected filter. We measure that on D8. In setup, we configure the S0 to S3 pins as a output and out as a input. The code sets. This selects the TCS3200 frequency scaling mode. Here 20% scaling, that reduced output frequency so the Arduino can measure it reliably with pulse-in function. The read color function selects the filter by toggling S2 and S3, waits 50 microseconds for the sensor output to settle, then calls pulse-in out low to measure the duration of a low pulse. Pulse-in returns pulse width in microseconds. Shorter pulses mean higher frequency, a stronger reflected color signal, and vice versa. In the loop, the code calls read color for red, green, and blue, storing the results in red frequency, green frequency, blue frequency. Then, map function converts the measured pulse widths, assumes between 30 and 300 microseconds, into a 0 to 255 range. Notice the order 255 0. This inverts the measurement because a smaller pulse, higher frequency, stronger reflection should map to a higher brightness value. Constant clamps value so nothing exists the byte range. Get color name. This function receives the mapped RGB integers and uses a sequence of threshold checks to name the color. The logic is grouped and ordered for best match. We clear the screen and draw the label, color, and the detected color name. The display.display call sends the buffer to the OLED so the user sees the updated result. A small delay 300 slows the loop to a user-friendly refresh rate. Now connect your Arduino Nano to your PC or laptop using a USB cable. Once it is connected, open the Arduino IDE and load the code file, which you can download from the link given in the description. Make sure you have the required library installed. I have already installed them, so I am skipping that part in this tutorial. Next, go to the Tools menu, select the correct board and COM port, and then click the Upload button. The code will be uploaded to your Arduino Nano in just a few seconds, and you will be ready to test the project. Now connect all the components exactly as shown in the circuit diagram. After completing the wiring, power the Arduino Nano using the USB cable. Once the system starts, try placing different colored objects in front of the TCS3200 color sensor. You will immediately see the detected color displayed on the SST1306 OLED screen. It is a simple and satisfying way to visualize how the sensor reads and identifies color in real time. If you enjoyed this tutorial, then do not forget to subscribe to our YouTube channel for more exciting and upcoming electronics projects.